Hi, well, it's a snowy day, and I'm sitting here teaching you a new lesson about solving quadratic linear systems. Okay, so a quadratic, and we've talked about systems of equations, and you guys actually have solved them, and we're pretty good at it. But when we were solving systems of equations, we were solving linear systems of equations, where there was two equations, two variables, and both of them were linear equations. So if we're going to solve a quadratic linear system, two equations will be given to you, and you'll be told to solve them either graphically or algebraically. And one equation is going to be quadratic. And remember, that means that the highest exponent or the highest degree is 2. And the second equation is going to be linear, therefore called quadratic linear systems for a reason. This equation is going to have the highest exponent of a 1, so it has a degree of 1. Now, very similar to systems of linear equations, where the two graphs intersect, this is your solution, okay? So let's just discuss what can happen if you have a quadratic and a linear system. So there's 3 possible situations. I could give you a quadratic, beautiful parabola, like that, and I can draw a line through it because it's a quadratic, so a parabola and a line, so a linear system. So I could draw a line and it could cut through the parabola like that. And as you can see, there are 2 very distinct intersection points. So we could have 2 intersection points. 2 intersection points. Another situation that could occur is that you have a parabola. Sorry, my parabolas aren't so great on here, are they? And the line touches it just right in one place, just at the edge of it. And that would be one intersection point. So it doesn't cut through it. It only touches it at the vertex or one of the sides of it. So one intersection point. And then the other thing that could happen is that you get a parabola like this. There's your parabola. And a line doesn't intersect it at all. So 0 intersections. All right, but the process is very similar to when we solved algebraically systems of linear equations. The first thing you're going to do is you're going to make sure that both equations are in the y equals form. So, and then we're going to use substitution. So we need to get there. We're going to get a new quadratic equation when we do that, and we're going to have it in the standard form, and then we're going to solve. Okay, so we're going to solve by factoring. But the new equation is going to be quadratic, okay? It is going to be quadratic. So you're going to have to factor to solve for x. That tells me that I should get, most times, I should get 2 answers. I may not. I could get 1, but I should get, because it's quadratic, 2 answers. And then once we get our x value, we have to find the value of y by substituting our x answer into one of the equations. All right, so let's look at it. It says solve the following system. So you can see that we have a quadratic equation and a linear equation. First step would be to put them in y equals form. These are both in y equals form. So we can use substitution, and we're going to take the 2x and we're going to just plug it in for y in the other equation. So we get 2x equals x squared minus x minus 2. All right, so now it's a quadratic equation. So we have multiple ways to solve it, but I'm going to get it set equal to 0. So I'm going to subtract 2x. And I get x squared minus 3x minus 2. And I'm going to move the 0 to the other side. Now, I have my choices. Do I want to factor, complete the square, use the square root method, or use quadratic formula? Well, this is odd, so I'm definitely not going to complete the square. And that's a linear term, so that means I'm not going to take the square root. But to be honest with you, what have we always said is the easiest? Solve by factoring. So we're going to factor. So I'm looking for the factors of 2 that add to 3. So let's see. Oh, and it was a plus 2 up here, sorry. Okay, so that's going to be a minus 2 and a minus 1. They multiply to give me a positive 2, and I'm going to just check them out. They give me a negative 3 when I add the inner and outer terms. All right, then I set each one equal to 0, so x minus 2 equals 0, and x minus 1 equals 0. And then I get an x value of 2 and an x value of 1. All right, but we have to find the corresponding y value. All right, so I'm going to take the x. I'm actually going to go to the easier of the two equations, and I'm going to plug it in and solve for y. So y equals 2 times 2, which gives me 4. So my coordinate point of intersection would be 2, 4. And then I'm going to plug in 1, so y equals 2 times 1. And so that y value is 2, so that coordinate point where the line intersects the parabola is 1, 2. So just remember, when you're finding points of intersection of anything, it's really where the graphs equal each other. So I just find a way to set the graphs equal to each other. All right, you try one. This next one. So I want you to try it, and then I'm going to so pause the video and then come back on and check to see if you did it right, okay? All right, so I'm going to take this equation and get it in y equals form. So I'm going to subtract the x to the other side. So y equals 1 minus x. All right, and then I'm going to take that value, I'm going to plug it in to the other equation for y. So 1 minus x equals negative x squared plus 4x minus 3. I'm going to get it into standard form, so I'm going to subtract 1 and add x. Subtract 1, add x, and I get negative x squared equals, plus 5x minus 4 equals 0. All right, so normally I would solve by factoring, but really I don't want to factor because that's got a negative in front of it. So I wanted to divide that guy out. So I'm going to divide every term by negative 1, and that's going to flip the signs for me. But it's going to make that x squared positive. Again, at this point, we're going to solve by factoring. So we factor. So I'm looking for the factors of 4 that add to 5, so minus 4 and minus 5. Minus 1, sorry. And those do add to a negative 5. So I set each one equal to 0. So x minus 4 equals 0 and x equals 4. X minus 1 equals 0 and x equals 1. Don't want to forget, we plug that value back in to find the corresponding value of y. That's the easiest place. So 1 minus 4 gives me negative 3, and then 1 minus 1 gives me 0. So this parabola and this line, they intersect in two distinct points, 4, negative 3, and 1, 0. So hopefully you got that right. All right, so multiple choice question given, which is the solution of the following system of equations? Okay, they're both in y equals form. So I'm going to take 2x minus 15. I'm going to plug it in for y in the other equation. So 2x minus 15 equals x squared minus 6x. The nice thing about multiple choice is typically if you get the x and there's no other answers that have that x, then you're kind of done at that point. So, all right, so I'm going to set it equal to 0. I'm going to subtract 2x. I'm going to add 15. Get it into standard form of a quadratic, and I get minus 8x plus 15 equals 0. And again, I just like that 0 on the other side. So, all right, now I solve by factoring. So I get x minus 5 and x minus 3 equals 0. The factors of 15 that add to 8 are 5 and 3. All right, so x equals 5 and x equals 3. So I guess I do have to keep going, don't I? Because you might see it's not 2, so I can eliminate that, and it's not 6. But I don't know which one they gave us. So I'm going to start with 5, and I'm going to plug it into the easier one of the two equations, so the 2x minus 15. So y equals 2 times 5 minus 15 gives me 10 minus 15, which is negative 5. So it will be 5, negative 5, and then I plug in 3, so y equals 2 times 3 minus 15, so 6 minus 15, which is negative 9, so 3, negative 9. So my answer is going to be 1. Okay. All right, so the last thing I want to show you how to do is how to do this on your calculator, because we just did it algebraically, but the calculator actually can be really easy. So if you can get your calculator out, the first thing that we're going to do is we're going to go into the y equals. So up in the top left corner, you can see the red button on the screen. And you're going to plug in the equation x squared minus 5x plus 6. I'm going to clear the rest of it out. Sorry. X. Oops. I'm having trouble here. Okay, so x. All right, let me start back up. Clear. All right, so x squared minus 5x plus 6. Okay, so you put both equations, and they have to be in y equals form, and then you go to graph. Now, when they graph, you're going to see a nice parabola. There it is in blue. And then you should see also a nice line. Now, in this case, it's pretty clear and evident that you can see the right here is a intersection point, and right here is an intersection point. So I'm looking at this, and this looks like what? 1, 2, 3, 4, 5, 6. So this looks like 0, 6. Okay. And the other one appears to be about, let's see, 1, 2, 3, 4, 1, 2. So 4, 2. All right, but we're going to check graph. We're going to check with our calculator. So to check for the intersection point, if it wasn't so clear, you'd press the second button and then calc up here. And you may see now on this calculate, there's an intersection. So I'm going to go to number 5 and press enter. Now it's going to ask you for the first curve. Now I want to be above the intersection point a little bit, so I'm going to go above it. And I'm going to press enter. It's going to jump to the other line. So now it's on the red line. So I'm going to go a little bit farther to the right of it. I'm going to press enter. It's going to ask you if it wants to guess. And it's giving 6. And it's a little bit off here, but it would be 6, 0. All right, so now I'm going to go to the other intersection point. So I'm going to go to second calc, intersect again. But now I'm going to head all the way over to this side of the graph, right about there. Press enter. And then I'm going to trace until I get to the other side. I'm going to press enter again. And I want it to guess. And it gives me the intersection point of 4, 2. So we were right. And so 1 would be our answer. But be really careful because look, 2, 4 is an answer as well. And it's tricky because some of you may decide, might look too fast and pick 2, 4. So you just really want to be careful on these. All right, guys, so that was systems of quadratic linear systems. So I hope you didn't find that too difficult since we've done that before. And I'll see you tomorrow in class so we can review a little bit of this. Have a great night.